In this video, we're going to do a quick review of chemical formulas and how to count atoms because that's going to help us with remembering how to balance equations, which we'll do eventually. So remember that rather than represent elements by names, we can use symbols, and we can do the same thing for molecules and compounds. We can use what we call chemical formulas because they are universal. Everyone understands what H2O is, even though in French it's de l'eau and in English it's water, or aqua in other languages, in Italian, for example. Um, H2O means the same thing everywhere. So it's nice and universal. The chemical formula has a couple parts to it. First of all, there's the symbols of the elements that make up the compound or the molecule. So we have hydrogen and oxygen. And then there's also what we call subscripts, these little numbers over here. So the 2 means how many hydrogens are. There's 2. And then there's no number next to the oxygen. So when there's no number there, it really means there's 1 there. But you don't have to put 1, but there's 1 oxygen. So the chemical formula for water, being H2O, contains 2 H's and 1 oxygen. And so that's just basic counting. Subscripts are the small numbers again, sub meaning small or below. And again, if there's no subscripts, you assume there's a 1. So we can do a couple practice problems. If you're pretty quick with this, you can move ahead of the game a bit, but pause the video and try it out, see if you match with me. So here we don't have a number, so we know that's 1 calcium. And then we have a number 2 there, so 2 chlorines. Total would be 3 atoms total. How many different elements are there? Well, there's calcium and there's chlorine, so there's 2 different elements. So there's 3 atoms total, 1 calcium, 2 chlorines. But if I were to ask how many different elements are there, there's 2 different elements. So let's go ahead and try the next one here. 2 sodiums. For sulfur, be careful. There's no number next to sulfur, so that's a 1. For oxygen, that's number 4 there. So total, there's 2 plus 1 is 3, so 7 total atoms. How many different atoms are there? There's, well, sodium, sulfur, and oxygen. So there's 3 different elements in there. So basic counting like that is pretty straightforward. You just look at the subscript and you tell me how many atoms there are of each element. So number of each atom type, for example, here there's 1 carbon and 2 O's for a total of 3 atoms. So what you can do is pause the video, try this yourself, and then check my work, and I'll do that pretty quickly. So here we have 1 carbon, 1 O for a total of 2. Here we have 2 H's, 1 O for a total of 3. Here we have 1 calcium, 2 chlorines for a total of 3. Here we have 2 aluminums and 3 sulfurs for a total of 5. And here we have 1 sodium and 1 chlorine, or I should say chloride because it's the ion, for a total of 2. Next, we're going to go and try counting, but this time we're going to take a look at compounds that have brackets this time. So sometimes you'll have a compound with a bracket, and the subscript is outside the bracket. So what you need to do is multiply everything on the inside of the bracket by the subscript. Anything that's outside you leave alone, but anything that's inside you would multiply by the subscript. So for example, here we have 3 calciums. We don't multiply that by the subscript because it's not inside the bracket. For oxygens, we have 2 times 4. So for oxygens, we have 8 oxygens. And for phosphorus, we have 2 times 1. So 2 phosphorus for a total of 13 atoms. So if you understood that, you can pause the video and try this yourself, and then unpause it, check your answers after. So here we have aluminum nitrate, and again, you can practice naming if you remember that. So we have 1 aluminum. For the oxygens, we have 3 times 3, so 9 oxygens. And then for the nitrogens, we have 3 times 1, so 3 nitrogens. And that's a total of 3, so 13 again. Here we have 2 aluminums. 3 times 3 oxygens, 9 oxygens. 3 times 1 carbon, 3 carbons. So 12, 14. Here there's no brackets, so it's just like normal counting. So sodium carbonate, we have 2 sodiums. We have 1 carbon. We have 3 O's for a total of 6. And that's how you count if you have brackets. Make sure to multiply everything inside the brackets by the subscript. And another situation you might see is when is a coefficient. So a coefficient is a big number in front of the formula. It doesn't modify the formula itself. It just tells you you have that many of that molecule. So for example, if I have, let's say, 3 H2O, what this 3 is telling me is I have H2O, H2O, H2O. It means I have 3 water molecules. But rather than write H2O, 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 I simply put 3H2O. So when you're counting atoms and there's a coefficient in the front, you multiply everything by the coefficient. So I'll do an example. In this table, I'm first going to start off by counting the number of each type of atom before multiplying. So typically I'd have 1 O if there was no 6 in front and 2 H's. But now that there's a coefficient of 6, I have to multiply everything by the coefficient. So times 6 times 6. So this really means that there's 6 oxygens and then 12 H's for a total of 18. And that makes sense because if we had just one water molecule, there'd be 3 atoms total. But we have 6 water molecules, so 6 times 3 is 18. So over here, let's pretend a 2 is not there at first. The coefficient of 2 is not here. We'd have 1 calcium. We'd have 2 chlorines. Now let's actually go and apply that coefficient of 2. So multiply this by 2, so that's 2 calciums. Multiply this by 2, that's 4 chlorines. Right, so it's kind of like saying CaCl2, CaCl2, right? So here you have your 2 calciums, and here you have your 2 plus 2, your 4 chlorines. And so here we have a total of 6 atoms. So same idea here. If we didn't have a coefficient, we'd have 2 aluminums, and we'd have 3 sulfurs. Now with our coefficient applied, which is 3, we multiply everything by 3. And so we have 6 aluminums, 9 sulfurs, 15 total. And the last one, same idea. First, pretend that coefficient's not there, so we'd have 2 aluminums. We'd have 3 times 3, so 9 oxygens. We'd have 3 times 1, 3 carbons. And now multiply everything by the coefficient. So times 2, that's the coefficient here. So we'd have 4 aluminums. Times 2, so we'd have 18 oxygens. Times 2, 6 carbons. And so you add these together, it's 4 plus 18 is 22, 28 total. And so that's how you would go about counting atoms if your formula had a coefficient in the front. It's still, this 6H2O is still water. We're just saying we have 6 water molecules. This 2CaCl2 is still calcium chloride. We just have 2 units of calcium chloride. I'm saying units because remember this is ionic and it doesn't exist as molecules. It exists as crystal structures. So that's why I'm saying units instead of molecules. That. So one more important skill that you need to have is going from a structural formula to a regular chemical formula. And so a structural formula, just to simplify it, is a picture that shows you how the elements within a compound are bonded, as you can see here. But we don't always want to draw these out. Yes, you do want to know how to draw these out. You will learn that, but you also want to draw them as chemical formulas. So typically you just write down what you see with subscripts to explain how many atoms there are. The order you usually follow is C, H, O, and then other. So for example, H before O here. So I'd have H, there's 2 of them. O, there's 1. Here, C before H, so I have C, only 1 of them, don't have to put the number. H, there's 1, 2, 3, 4. Here I have, so C before other, so C, only 1. Cl, there's 1, 2, 3, 4. And here O, there's 2. So you can go from this picture to this chemical formula pretty easily. And this year we're going to learn how to go from the chemical formula back to the picture. You might already know how, but for now, really, I expect you to be able to go from the picture to formula. And so you should be able to do practice problems like this. being able to identify what elements are found in compounds, how many there are. And so there's a few practice problems included in the following slides. I will post an answer key for you to try out. But first, make sure you have watched the entire video so you can actually go through these problems afterwards. They're just more counting problems with some guided questions. And here you have a table where you have to count the number of atoms found within the compounds, just like we did in previous examples.